It is a giant pleasure for me to be here today to talk to all of you. The next part of the BizTalk and integration journey sort of at Microsoft has obviously begun, and we have a lot of really interesting stuff. And the way how things are shaped, and I haven't been able to be here yesterday, and I'll explain why. But you see that there's kind of these fundamental services under the covers, and then there's all the higher value services that sit on top of it. And I think today, for the first time, we're really showing, or this conference, the first time we're showing kind of how they all hang together in a very reasonable way. So I'm very happy about that. I'm going to talk about a few aspects of messaging here. I'm going to talk about some standardization efforts that are ongoing, that we have completed and that are ongoing, what we're doing with those. I also will talk about premium messaging and what premium messaging means relative to standard messaging in Service Bus, in the Service Bus messaging product. And then I have one slide which I call the speculation slide, where I decided not to write a lot of stuff down, but I will tell you a few things. I will do that in a form that Dan doesn't rush here up on stage and tries to kill me. And since Dan has been talking about his journey and has been advertising his book, I also wrote one. You can get this off Amazon for 50 cents. And it sold, like when it originally was on the market, it was a 6-month terrible time writing this book. And it has really pretty graphs and how the BizTalk architecture hangs together, which are curiously still work. It has some introduction about the speculation about the future, because this was the first XML-based integration broker. So I wrote some really speculative pieces in the first few chapters on how that would play out, and some of that actually played out that way. So if you are into kind of historical books, that might be one to go and get off Amazon or AB Books or any of those used bookstores. I made absolutely no money on that book. So we're all messengers, messengers have a long history. So here we have the Pony Express, wanted young, skinny, wiry fellows, not over 18, must be expert writers, willing to risk death daily. Since then, we have progressed quite a bit. We took some stages. Before I go, and so here's a mailroom with pneumatic tubes, and that's also messaging. And there's a lot of people who are messengers. All of us are messengers in the room. So I want to take a moment here to do something that is near and dear to my heart. For someone who is a friend and enemy sometimes, and who is a fabulous person. I don't know whether you all knew ZeroMQ. ZeroMQ is a infrastructure, a very low overhead way to pass messages around, and someone wrote this thing or initiated that thing. His name is Peter Hintians. Do you know Peter Hintians? Who knows Peter Hintians? A few of you do. So Peter is a luminary on the other side of the world in Linux land, and he's all about open source, and he despises patents. So he's kind of on the other side of the world from us, but he's a messenger. And sadly, Peter has terminal cancer, and he's fighting a hard fight. He's also publishing that on Twitter. And so one thing I would like to do, and because we're recording all this, I would ask you for a fellow messenger just to give him applause of encouragement. Thank you. That was very nice of you all. So, and he's in good spirits. He's fighting like a fighter, so I hope that's going to help him a little bit. So let's go and talk about messaging and the success of it. Because he and all the other folks who are building messaging platforms, who are building messaging protocols, are part of this story. When I wrote that book in 2000, Yeah, integration was necessary, and you had some options for messaging. We had MSMQ in Windows. There was MQ series, and it was used in some systems, but it didn't play a central role. It was kind of a thing that just happened, that existed by the way, and the only place where it really had a central role was in banking and insurances. And a lot of us have backgrounds in insurances and banking because that's where it all came from. Since then, a lot has happened, and it has to do with scalability, it has to do with the cloud, it has to do with also the Internet of Things in particular, where that's now kind of driving a lot of new traffic, and with a desire to have deeper operational insights, which means we need to go and take logs and need to go and flow those logs, and that's what's driving a lot of the traffic that you've seen, and I have that slide again that Dan showed you on throughput that we have on Service Bus. We have a lot of new protocols that have emerged. We have AMQP, and AMQP has started, and actually Peter, who I just mentioned, was author of one of the few, or co-author of one of the earliest versions of AMQP, is a robust symmetric message transfer protocol that now provides customers with an open choice for protocol. We are in a world still where some of the incumbents in the messaging space, and you know this as well as I do, and we're actually going to have some talk about that later today, I believe, are still sitting on proprietary protocols, and proudly so. One example for that is the company which also promotes MQTT, the MQ telemetry transfer protocol, and the MQTT protocol is something that complements, that was the initial intent, MQ, so MQ series from IBM. So IBM made MQTT as an open protocol that can go and fan in SCADA data and telemetry data into industrial systems, but then the intent was to go and do all the heavy lifting messaging on MQ proprietary protocol, and that's still something that you'll hear IBM people say, including Andy Stanford Clark, who I talked to recently about that whole thing. So the nice thing about messaging and the surge of messaging is that we get new shapes, new ways of using messaging, and new combinations of patterns kind of codified as products. So I have these high availability, high scale message brokers like the one that we built with Service Bus. We have these event ingesters like what we do with Event Hubs or what you see in Apache Kafka. We have these bidirectional IoT gateways, which we built with the IoT Hub. And we have large-scale event distribution capabilities, such as notification hubs. And all of them are playing off patterns, but they're built on the same principles based on the same foundational infrastructure. So the slide that Dan showed you is very significant in showing what the progress has been. 2.75 trillion messages per month in ingress represents what we get through the system through the public deployments. That represents well over 10 trillion messages which are actually being pulled out of those event hubs. That's a huge number. The 350 billion transactions that we run through messaging, that we run through a reliable transactional message broker, is also significant. So, and that trend continues, like the growth rates we have internally, even on a service that we haven't really talked about much, I'm going to talk about that at the end, the relay. We have well over 10% growth month over month on the relay, even though we don't say anything about it, really. And that's our fault, and I'll tell you why. It's not dead, it's not dying, it's actually getting better, just so that you're not nervous during the talk. Let me talk first about protocol standards engagements, because that's something that continues to be really, really important. We keep believing that integration, the key for integration, the key to make integration easier happens on the wire. So AMQP is one of the protocols that we bet big on, and we continue to bet big on. And AMQP is gaining traction, it's gaining more traction, and one way it's also gaining traction by inclusion into other standardization efforts. So AMQP is now becoming the default protocol of Service Bus. So Service Bus has a story of effectively supporting three protocols. One is HTTP, one is what's called SBMP, which is effectively NetTCP WCF, the WCF version of NetTCP, if you will. that has a protocol overlaid over it. We're now replacing that completely with AMQP. We still have to have a few gaps to close. Like transactions don't work with the AMQP protocol yet, but that's not a deficiency of the AMQP protocol per se, but that's just a matter of catching up with the features from one protocol head to the other protocol head. AMQP, what's interesting about AMQP 1.0, which we support, versus AMQP 0.x, specifically 0.9, and there's also 0.10 version, is that they only really share the name and some aspects of the data encoding. AMQP 1.0 is a transfer protocol and doesn't have any particular leanings towards what the topology behind the protocol needs to be. It doesn't have a notion of a queue, it doesn't have a notion of an exchange, it doesn't have a notion of any particular shape of the broker, which makes it adaptable to all the things that we built. There's stuff that we do with AMQP, for instance, event hubs, which you just couldn't do with the old version of the protocol. An event hub is a queue from the front, but it's a tape drive from the back. That's if you want to think about the patterns. That tape drive notion is something that you just cannot model correctly in the old AMQP protocol. So any broker that's sitting on that 0.9 protocol is kind of baked towards that notion of topology, and that's something that we didn't want, and that's why AMQP 1.0 turned out the way it did. Just as a quick intro, in case you're not familiar with it, let's go through this quickly, what it does. So first of all, it's multiple layers. There's a frame transfer protocol at the bottom. And the frame transfer protocol of AMQP has the notion of container, and container is the parties you connect. There's a notion of connection at the very bottom, so a client, and the client's only valid, that's only matters for connection, goes and connects to a server, and that's creating the connection. The connection can then be secured using SASL. Then you have a connection. As soon as you have a connection, the whole notion of client and server just vanishes. It's no longer interesting for any of the following exchanges, which is really important. Because now with that, you can realize this flows where the server decides it wants to go and initiate a link to the client and vice versa. So it's a fully symmetric protocol above the connection layer. Then you have these. Then you have the containers, a notion of containers and nodes. A node is just a name. And if you're familiar with Service Bus, in Service Bus we have this graph, a tree of names that you can go and pick whatever name you like, and you can go and organize the names that you like. And in other brokers, there's a flat structure where you simply have just queue names. And so AMQP allows for both of these. The parties you communicate with are nodes in AMQP. And then you have a message transfer protocol, and the message transfer, so the underlying part is a frame transfer protocol. How do we move frames from A to B? And then with the introduction of nodes, there's now a message transfer protocol that sits on top of that. You create a link with another party. On that link, that can be outbound, so you can send messages, or you can do an inbound link where you ask for messages. The way you ask for messages is you book credit. And that credit then gets satisfied by sending messages to you. So there's no receive gesture. You simply say, you have 100 messages credit, fill them. The nice thing about that is you can book one credit, which is receive, or you can book max int credit, which means you want to have a continuous stream delivery. And you can go and throttle with that very nicely. And either party it's okay for either party to go and open up those links and close those links, so it's fully symmetric. That's how we realize, for instance, on IoT Hub, a model where you have a device connecting into IoT Hub to get through the firewalls and everything. The device can now go and create a link to drop off its telemetry to a node that's the telemetry node. At the same time, you can go and you can send a command to the device where now there's a dual link, right, outbound from the hub and then inbound into the hub, which forms a bidirectional channel which then sends the commands to the devices, and that all happens through the same connection. So it's a multiplex protocol that allows for unidirectional flows, telemetry in that case, and command and control is a bidirectional flow, and that can all be done on a single connection using the AMQP protocol. And it's at the same time super compact. More on standards engagement, and related to this is what we do with the OPC Foundation. Who knows OPC? Some of you do. So the Internet of Things is going to be your future, whether you want it or not. The Internet of Things is going to be something that will touch every single integration company on the planet, because there's money and there's need, and that need is going to rise very rapidly. OPC UA is a standard, or the OPC Foundation is an association of 450 automation companies and a few IT vendors who have come together to define, about 10 years ago, to define a standard for how industrial equipment, factory equipment, can talk to each other. And not on the real-time bus, but really how do you coordinate a factory? How do you coordinate flow between the machines? How do you coordinate a production line? How do you get diagnostics data out of it? How do you do the higher level orchestration of industrial machinery, which has been a space that has been super proprietary for the longest time? They have seen what we all have seen in the early 2000s, and that is, well, we can't do it with all with proprietary stacks. We really have to go and make things compatible. So what XML did for us is basically what OPC UA does for the automation industry. What OPC UA does, though, is they do not try to invent new protocols, but they try to go and assemble what is there in existing technology and use that. So one of the things that they ask us for, and that's why we engage, and I'm sitting on the working group of OPC UA, and that's actually why I couldn't be here yesterday, because I was at the working group meeting in Erlangen in Germany, how can we go and take industrial machinery and connect it to the cloud, or can connect it into IT systems? So, and we're doing an integration, and that's a specification that's being written, not by me, but by the folks in the working group, and I'm just a consultant effectively, that is about publish and subscribe integration for industrial machinery. And what we showed at Hannover Messe, it's the biggest industrial trade show in the world, a few weeks ago, was a living example of that, of how we can take existing industrial equipment and integrate that very easily with the cloud. And the way to make this possible is to integrate OPC UA with the AMQP protocol, so that industrial devices can natively speak AMQP and can go and now emit data into the pipeline that is in Azure, but also in pipelines that are in other on-premises systems. So we're trying to normalize towards a small set of protocols here to do this. So 2 examples. So you have an industrial device. The industrial device is called an OPC UA server. That's a little bit of a weird notion, because you think of OPC, you think of devices as clients, but really here it's the thing you want to have data from. Right, that's the server. That's why it's called server, because it has the information. That's a little bit, it's nomenclature in that world. And that will now go and collect information. You have a standing query, if you will, and that will then flow information over AMQP into event hubs. And then from event hubs, further down to Spark, Storm, and ASA, and into applications. One thing that OPC UA has, that standard, is they have a binary schema-bound encoding that is on the wire as you talk within the factory, because they need to have small packets, they need to have fast speeds. But for integration with the cloud, for that AMQP path, for the PubSub path, we standardize on JSON. We standardize on JSON because I said, look, you could have as much of your wonderful encoding over here, but nobody's going to care in Hadoop. So we made the standard such that it emits data in a way that is easy to pick up from any system that may be downstream in the cloud, just to optimize for integration. Service bus, same way. Because we use AMQP, and because AMQP is just a transfer protocol, it doesn't have any specifics about whether you talk to a queue or a topic or an event hub or any of those things, we can do exactly the same thing here. So we can go and use the OPC UA server, and the OPC UA server is then able to go and talk to a queue. Now, one thing we also have is, and that's an aspiration that we have, I'll talk about that later a little more in the future section, is the relay, which is currently, the service bus relay, which is currently bound to the UPCF, is obviously, needs an overhaul, we know, and the logical place for the relay to go is to speak AMQP. And once you speak AMQP with a relay, well, then you have a dual channel you can go and use. And that dual channel is something that is a specification, a relay specification in OPC UA that will also then match up. It will make it possible to go and relay to OPC devices, native industrial devices, through the relay that we've built, and access those services very nicely. And then IoT Hub is already doing this. The IoT Hub folks have, so that's our sister team, if you will. The IoT Hub team has already shown that integration. They're able to control OPC UA servers, so what means industrial devices from the cloud, and they can go and orchestrate things from the cloud, and that was the big hit that we had at Hannover Messe. So we're doing a lot of work to kind of try to bring messaging, to include messaging in the future, and to bring it into the future and try to help opening up new markets for integration folks. And there's a huge, huge demand that will be there to go and take industrial environments, and that goes from energy to manufacturing to oil and gas to like all kinds of industries, and open up the data streams that exist for integration and for then dispatching that data to appropriate systems. So that's groundwork that we do on the standardization front. Let's move to product from standardization. The broker platform options, so Dan talked about event hubs, which is a separate service for us. Let's talk about just the broker, just Service Bus Broker. The broker platform options you have today are Service Bus for Windows Server 1.1 or Windows Azure Pack Service Bus for Windows Server 1.1, and the public cloud standard and the public cloud premium. It's one set of protocols and compatible client APIs. Yes, there's some delta because we've done a lot of work since we released Service Bus for Windows Server 1.1. But generally, if you know how to use one, you also know how to use the other. The capabilities are across the broker are largely consistent. There's a few features that are not there, but you can get the assembly for Service Bus for Windows Server, and then you can get the assembly for the cloud. And if you're a little careful, then your code will work against both. From the update cycle, and this is kind of where it diverges, is the Azure update cycle is factually every few days. In terms of new features, it's every few months. We have usually bigger releases aligned with bigger events, so every 6 months or so. And then on Azure Pack, and I'm specifically talking about Azure Pack, remember? Not Stack yet. On Azure Pack, well, that's that update cycle of server. But the server hasn't been updating in quite a while. So we shipped on the day that server 2012 R2 shipped, and then we haven't shipped really since then. Except for we've done the necessary work to do updates and to do servicing, and we do get servicing calls every day, and we do bug fixes. We do a lot of stuff on that server, but we haven't done a major feature upgrade because on that server lane, there hasn't been a lot of activity in terms of new features. So that's what they are. That's what the options look right now. So we have a multi-node clustered message broker, AMQP, REST support, queues, publish, subscribe, talk. So you have all of those things consistently across the platform. Sequencing, arrival timestamp, peak log, expirations, dead letter, all the things that are there are across both platforms. So they're both on premises as they are in the cloud. The cloud has some extra things. There's a few features that don't exist in the old version just because we have progressed since then. And there's also partitioning is not there. And there are differences in terms of what the baseline is now from the storage engine, and also who's managing those things. So I'll talk about the differences in the storage engine when I get to between Premium and Service Bus when I get to Premium in particular. One of the reasons why we chose SQL here, the SQL store, for on the on-premises version is because, and that was a decision that we made 5 years ago, was that we wanted to give you a store that you can manage, and that where we have tools in existence that make it easy to manage, where we have infrastructure to do backups, et cetera, et cetera. We have now, meanwhile, moved on from SQL for Premium Service Bus, so that has some consequences for what the strategy is going to be for on-premises that I'm going to get to a little bit towards the end of the talk. The programming model platform options have expanded quite a bit, and that is even not the current picture, because that's changing very rapidly. So first of all, AMQP is our primary protocol now. Right? SBMP is still something that we support, and we continue to support it as long as the client libraries are out there. Yes, there are still some features which are SBMP only, like transactions, but we're going to move those over within the next several months. That work is well underway. We have the .NET Service Bus SDK, so the primary assembly, and if you're on .NET, that's probably what you use because that gives you access to all the features. And on top of that, one of the things that we have is the WCF net messaging binding. So if you're still doing WCF, that's a wonderful way to use queues and topics, is to just use the net messaging binding through that, and that's fully supported as part of the client, and that will work. For the universal Windows platform and for the core CLR, Net Core, and for Mono, we have SB Lite. That's a contribution from the community that sits on top of AMQP Lite, which is not a contribution from the community, which we actually make ourselves. So our folks who are building the AMQP stack built AMQP Net Lite, and that is a AMQP stack that runs on .NET and runs on every version of .NET from the micro framework on up. So it runs on the compact framework, that still exists, and it runs on all the different variants of the .NET framework, and it also runs on .NET Core, and that gives you a core AMQP stack that can do everything with. For anybody who's using C and C++, we have two stacks, both of which we help with. One is Apache Proton C, so that's the Apache Cupid project, and they have a stack that has two shapes. There's one that's an imperative API, that's the messenger API, that's so-so. And then there's a reactive API, which is a lot better, which is also what the IoT team is using. That's a great thing. And so that's a C core written in C99 that you can also go and take everywhere. And they also have some C++ bindings. We have another stack that we built, and it's called Micro AMQP for C. That is a stack that is very new, and that's for embedded devices. So if you have small devices, they can go and talk AMQP now, and the footprint of micro AMQP is like 20K, I think, the in-memory footprint. So it's really suitable for the smallest devices. So we can go and scale from smallest devices to the biggest servers effectively with that entire stack. And then obviously we still have the HTTP bindings, but in the Apache Proton stack, there are bindings for a ton of languages up until, including Go and Rust and all kinds of additional languages. So mostly for AMQP, you don't have to use HTTP anymore. Generally, we would like to encourage you, and we're actually going to do some work on encouraging that I can't share yet, but Dan is heavily nodding. We're going to do some work on encouraging you to use AMQP over HTTP, because HTTP is not as efficient as a wire protocol, and it's actually more costly for us. And we want to make sure that we also reflect that in the future and do something on the monetary side to help you a little bit more on the AMQP horse. But details on that will come at a later conference. But AMQP is the protocol of choice. AMQP is what you should be using. I'll skip that one. So we have in messaging, across all those different capabilities, we have a lot of features. And those features provide a broad variety of capabilities, which make it hard sometimes to provide even performance. It turns out that doing all of this batching and dead lettering and duplicate detection and ephemeral entity support, and expiration and multiplexing and order management and scheduling and session state and transactions, all those things. And then do filtering in PubSub, all takes a lot of resources in very different ways. And doing that in a highly scaled system is very difficult. So that's the primary motivation for why we're now splitting up Service Bus into effectively two different tracks. One is standard, the standard product, and one is the premium product. Let me talk about that. So Service Bus Standard is, and never mind that I just skip a few slides, you're not going to miss anything. Service Bus Standard is PaaS messaging infrastructure. You don't have to worry about it. I say 15 global data center regions here on this slide. That's outdated. It's 20, I think it's 23 now. We got relay and broker messaging, so you know all those things. So that's the standard thing, the standard product, which we have started, launched in January 2010, and have since then expanded. What you get with standard today is you already get world-class scale, availability, and reliability. So we run these clusters at up to 128 front-end nodes and 128 back-end nodes. When I say node, I mean virtual machines. So the big clusters that we have 256 machines with 2 cores or 4 cores each. These are big clusters. And those big clusters host your queues and host your topics. And they do this in a very reliable fashion. So if you have in standard, so in the existing product, when something goes wrong, and believe me, in clusters of that size with those, I mean, this is backed by, but the standard product runs on top of SQL. We have thousands of SQL databases behind this. Because if you get if you make one queue, you can get up to 5 gigs of storage for it. So there's a lot of databases that we need to go and back this with. If you have thousands of databases with hundreds of nodes in a single cluster, and you have many of those clusters, a lot of stuff gets wrong. As Dan showed you, right, we run at effectively 5 nines. If you just round up that number just one by one notch, but we run at 5 nines, and we still have a lot of errors. So stuff goes wrong all the time. So how do we defend against stuff going wrong? So you have a request that comes into the message broker. The message broker owns a queue. So the way how the system works is that each of the nodes in the message broker, each of those 128 front-end nodes, each of those 128 back-end nodes owns a queue. And it needs to own it because there's a sequence number that we give, right? Every message gets stamped with a sequence number for that queue. Someone needs to own that sequence number. Well, that's the broker piece, the broker bucket for that queue that needs to live somewhere and needs to be the authority for something. That then goes to the message log, and the message log is one log, or in the case of partitioned entities, which I just skipped, is multiple logs that the data gets distributed on top of. What happens now if that broker node dies or gets upgraded? Well, we have back-end infrastructure in place, Service Fabric, that we run on top of, which then goes and effectively switches over to the secondaries for those queues, and then we'll go and keep that operational. That goes very fast. But what can happen is, if that happens, and it can happen through all kinds of different reasons, we will likely go and take the operation that you gave us, and we will fail that back to you. That's the mysterious internal server error. And then you can go and retry again, because we indicate that in the error is transient, and then you'll land on the right machine, and then we can go and execute. So that's all automatic. We don't need to worry about this, but there's an error rate that's just inherent to the system because stuff goes up and down all the time at those cluster sizes. The same is true for storage. Every storage element is triply replicated. If that storage piece becomes unavailable, we also fail over to the next one. With partitioned entities, you get even double security or safety in that way, because if the storage cluster goes out, if the storage account goes out, what we do is we make sure that one queue that is partitioned or a topic that's partitioned actually gets sharded across these fault domains, across accounts, that if one messaging cluster, one storage cluster doesn't feel well, that you still can go and send to the other one. So a queue never becomes completely unavailable if it becomes unavailable. Premium takes that a notch further. So Premium is a brand new clustering model that we introduced, and that is shooting for predictability. Because one of the things that is really difficult in what I just showed you in that picture is these clusters, 128 by 128, host tens of thousands of namespaces. So they're a multi-tenant model. And they're multi-tenant because we want to make messaging cheap for everybody. But cheap has limits. As Dan pointed out, there's limits to what you can do easily. So what we're doing is we're effectively creating clusters within the clusters. And what that gives you is a reservation of resources. It turns out that with the workloads that we run, with all the features that we have in Service Bus, are not I/O bound. They're no longer I/O bound, I should say. So we've done two things. So first of all, we have a brand new messaging engine we call Jetstream. And Jetstream is the messaging engine that we built for Event Hubs that is doing these trillions of messages a second, a month. It's not doing that quite much. Trillions of messages a month. And we put that underneath Service Bus. That was a 2.5 years journey to get that right. That runs now on blob storage. I/O performance is no longer a problem. But now the gating factor, now that I/O performance is out of the picture, and it wasn't with SQL, but now with the new engine that's gone, the constraining factor is memory and compute. And if I want to give you predictable performance, I need to ring fence memory and compute. So that's exactly what you get with a messaging unit. If you go and buy Premium, you create a namespace and you assign messaging units to it. A messaging unit is like a small messaging-specific VM, if you will. It's not exactly true, but it's mostly true, but because with a messaging unit, we're actually pinning a core to your workload. And we're pinning a reservation of memory to your workload. And the way we're doing that is we're actually, in the operating system, we're reserving that for you. So we create a mainframe-like system, if you will, in that multi-tenant cluster. You still benefit from economies of scale, you still benefit from that big gateway, and you still benefit from all the defenses that we put on top of it. But where it actually hurts, where the jitter comes from in terms of performance, that is in compute and in memory. And we put that in a box, and we built these clusters inside the cluster. You still get failover. So we're effectively building with your 4 messaging units, you get a clusterable system inside the cluster that gives you dedicated resources and where you get very stable performance with no noisy neighbors. So that's creating predictability. And it's also creating predictable latency, and it's creating predictable throughput. So here, we can actually say, and Dan put this boldly onto his slide, so I'm going to repeat it. He said 3,000 messages a second per MU. Per MU. He's nodding. Okay, good. Let me repeat this. This is the first time we can say it, because in a multi-tenant system, someone shows up and just pushes traffic hard, and everybody else gets slower because now the system tries to go and do this all fairly. Now you can actually buy perf. So you buy 4 MUs, and you get 12,000 messages a second. And that's something that's brand new capability. So premium messaging, you effectively get the same story, and it's the same API. It's all completely compatible. It's the same thing, but you get dedicated capacity. And as we go GA, you're going to get 4 MUs in the beginning. That's the maximum for each namespace, and we're going to go and expand that out for folks who have greater needs for this. And the difference here is also, you no longer pay by the transaction. You actually pay for the time that you use that cluster, because we're now selling you effectively VMs, and it's going to be it's on a daily basis that we charge this. So you can't just go and flip this on or off for 3 minutes, but it's a prorated on a daily basis charge that we charge here. And that's something that we will do more and more of, is that we will try to go for predictability and reliability at the same time, You'll see actually more of the new features go into premium, because in premium now we have the flexibility to go and give you a choice of how much of your own capacity you want to use. You can run as many messages as you like through premium, as many messages as you can fit through premium without worrying about any transaction costs. That's predictable is also the pricing. So how you think about this? Right, the standard is super reliable, like the Boeing 747, but you sit with 350 people who you don't know. And premium is the private jet, right? It's just as reliable, it's just as fast. It's actually a little bit slower than the 747, but you sit in there all by yourself. So then, I saved myself 5 minutes for speculation. Because you see there's question marks, and I'm not going to say I'm not going to commit to anything on paper. But so I was at an event in Belgium in fall, and I got yelled at for, where's the roadmap for Service Bus for Windows Server? And like, yeah, it's dead. Nobody likes those anymore. You set up a trap, and I'm like, oh, sorry. No, I didn't. So Service Bus for Windows Server is a very interesting story. Service Bus for Windows Server was built for, was primarily motivated by SharePoint and workflow and to sit on top of it, and that's actually was the motivation for shipping it. We are very surprised by the success of it, even though we've kept it super quiet. Like, there is a download, and the only advertising that we do is in WebPI. If you find it, there's a line, and that's it. And then, of course, there's the docs, but they have to be there. But it's growing like crazy, so we got to do something. That's story number one. So we're not going to strand you. Second, we announced something called the Microsoft Azure Stack. And the Azure Stack is the way how we're going to go and take the cloud to on-premises. It turns out that Service Bus is at its best, and that's kind of where we see the hottest installations, and which are the most interesting ones, is where it is actually a better product than any of the existing message brokers that exist, even the ones that you pay $4 million for. And that is, it's the only 5-way parallel load multi-node broker that you can install locally that does auto failover and that you don't have to worry about. You just set it up and it just works. Backed by SQL that you can go and manage. Take a look at MQ series, right? MQ is a primary and a secondary, 1990s cluster model. There's nothing like this. So that's the sweet spot. So what will happen is that there will be Service Bus and Event Hubs on Azure Stack. And Azure Stack will be the host for those two versions of Event Hubs and Service Bus. So that is the future. The future, Microsoft is committed to doing Azure Stack, which brings the Azure features to on-premises, and Service Bus and Event Hubs will both run on top of this. The timeline, I can't tell you, because Dan is going to kill me afterwards, and I want to live. But it's not science fiction. But I can also tell you it's not going to be this year. That much said to this one. We also know that there's desire to run, and the Azure Stack is, of course, that's at least 2 machines, right? So it's a cluster. And we believe that's actually the sweet spot for Service Bus right now. Then there's also the story of what happens with MSMQ. So, and that's something where we're just thinking right now. And the thinking right now is that we might go, and that's a might go, and have a version of Service Bus that's shrunk and that will also run outside of Azure Stack on server. So you can get a triplet where you get running it on server as a standalone thing, which is really, it's not built for. Like, if you run Service Bus for Windows Server on a single box, that's not the sweet spot what it was built for. And then you're going to have the on-premises private deployment version of this, and then you're going to have the cloud. And the goal is for all of those to be built and supported in a way that we don't have the situation as we have it right now, that we build a version and then let it sit there for 3 years, because that was clearly not a good idea. but have a sustainable model. And with the Azure Stack and with the fact that the entirety of Azure is now committed to that on-premises platform, which wasn't the case for Azure Pack, I think we have a realistic way forward there. So that's the future of Service Bus for Windows Server is Azure Stack, and that's going to happen. So you don't worry about it. Now, it's not going to be free. Oh, I can't tell you what the price of that is going to be because Azure Stack per se is not going to be free. And at least that's not what it looks like. We can't tell what the price of that is, but one thing we know is when we just put up one of the best message brokers in the world up as a free download, we made a huge mistake. Not because it sinks the company, but it's actually bad for our ability to go and ask for resources, to go and do expansion, to do support. Because if you go up to leadership and say, hey, I need 10 people to go and support this free thing, they're like, no. So I think we have to go and do something about that, and it's also asking for some money. But we're not going to break the bank, and we're certainly going to be cheaper than IBM. Most certainly. See, if I can sink that ship, that'd be fine. And then, I'm 1 minute over, but I'm just going to say one thing. The relay, I already alluded to the relay. We're going to put people on the relay. We're going to fix the relay. We're going to make the relay work cross-plat. And with that, we get out of WCF jail because we see the relay as being super attractive, so it's going to work. Certainly with AMQP, and then we're going to see, we have some other ideas to make it work really nicely from other platforms. But the relay also has a bright future, and if it's up to me, then the relay is also going to go into that new server. And I think that's what I had for the day. Service Bus Standard is awesome. Service Bus Premium is awesomer. And with that, I'll say thank you. It was fun.